Puzzles have always been fascinating, intriguing, and entertaining. In this work, we are interested in the making of burr puzzles, which are particularly attractive, complex and highly challenging to solve. Without the computer aid, such interlocking 3D puzzles are extremely difficult to design, and can only be developed by highly skilled craftsmen. What is burr puzzle? Basically, a burr puzzle is a 3D model that consists of interlocking pieces with a single key property. That is, when the puzzle is assembled, all its parts are notched, except one single key component which remains mobile. To construct these 3D puzzles, our building block is a canonical 6-piece burr. We call it a knot. It can be embedded in a 3D model to make a single knot puzzle, or connected into a network to make a multi-knot puzzle. Our method can enforce the single key property, so that the resultant puzzle pieces are connecting as well as interlocking, just as the bun is shown here. Case 1, single knot. This is a basic case of embedding a single knot in a 3D model. We first partition the knot into inner and outer parts, such that the inner part is still a knot. We then place the inner part entirely in the input 3D model, which is the squirrel shown here. After that, we can extrude the pieces with an anisotropic scaling till they go beyond the 3D model, and apply CSG intersection to extract the puzzle skeleton. We found that the interlocking property of burr is still unchanged after these operations. Finally, we can attach the missing volumes to the skeleton pieces to make a single knot burr puzzle. Case 2, multi-knot. Given an input model, such as this torus, we can design a network of knots inside the torus and specify the knot containing the key. The model volume can then be partitioned for each knot by the midplanes between them, and compute the shortest path tree, with the key knot as the root, for finding knot interdependence and orientation over the network. Then, we can place the inner part of a single knot in each partition volume and extrude them to produce the puzzle skeleton for each single knot. Finally, we merge those connected pieces and attach the missing flesh to generate the multi-knot burr puzzle. Results. General cases. The Lorana puzzle contains 4 knots in T-shape. This is an automatically generated animation by our visualization technique. The cubic box model has 8 knots arranged in a cubic shape. The horse model has a 4-knot network in L shape. We display this puzzle using wooden puzzle style. Extended cases. To arrange these 3 connected knots on dragon, we applied piecewise shearing to deform the puzzle skeleton without violating the motion space of pieces, which allows non-orthographic connection. To torus with 3 disjoint knots, we can merge puzzle pieces to connect them, but these knots are still independent. So, we add in tabs and planks to block the keys of the other 2 knots to enforce the single key property. Rapid prototype puzzle. This chess puzzle demonstrates the use of outer structure of the knot. We can have different appearance of some puzzle pieces replaceable while keeping the knot structure unchanged. We also display a rapid prototype puzzle for the torus we showed previously. At the very end of this video, we disassemble a mega box burr puzzle we generated with 4x4x4 array of knots